Variables. In an experiment, you change one variable, measure one variable, and keep all the other variables the same. The variable you change is called the independent variable. Its value is independent of the others. You choose it. The variable you measure is called the dependent variable. Its value depends on the others. Nature chooses it. The variables you keep the same are called control variables. For example, in an experiment to find how the length affects the time period of a simple pendulum, the length is the independent variable. The time period is the dependent variable. This is what you measure. Mass and amplitude of swing would be control variables. You must keep those the same. When asked to state some control variables, don't give examples that would be the same in any experiment, such as use the same stop clock. Also, don't just say the same everything else. Try to think of factors specific to this experiment that it will be important to keep the same. When plotting a graph, the independent variable goes on the x-axis, not forgetting the units. The dependent variable goes on the y-axis. The variables in an experiment can be continuous, which means they can take any value, for example height, force, current. For this you would plot a line graph. They can be discrete, meaning they're whole numbers, for instance number of people. For this you would plot a bar chart. They can be categoric. They have word titles, for example wool, cardboard, bubble wrap might be the categoric variables in an experiment on insulation. For these you would plot a bar chart. Finally, they can be ordered, where they increase in magnitude but with no specific link to the increase. For instance, small, medium, large, or slow, medium, fast. For this you would plot a bar chart. Most physics experiments will involve continuous variables and so will require a line graph. When you plot a line graph, you're saying that all the points along the lines are values that will occur. For example, if we measure the temperature of a substance as it is heated and obtain these readings, by joining with a line, we're saying that if we measured at any time between the 50-second intervals, we would find the temperature of the line. So for example, here we've measured at 200 seconds and obtained this value. At 250 seconds we've obtained this value. If we were to measure at say 223.2 seconds, we would obtain this value, and so on. Clearly this can't be true for categoric variables, as you can't have a substance that is 2/3 of the way between cardboard and bubble wrap, for example. It can't be true for discrete variables, as you cannot have a value of 5.234 people. It can't be true for ordered variables, as medium might be twice as big as small, but only 1/10 the size of large.